Hello, everyone. All right, today we are talking about addition and subtraction of rational expressions. So we're going to be working with some fractions that involve algebraic expressions, and figuring out how to add and subtract those. It's going to be a lot of coming up with the common denominator. So this is the last piece of our Swift Unit 1. And this comes from the section 3.2 in our Swift textbook. Okay, so let's talk about in general what our procedure is for adding and subtracting. So we need to make sure we're coming up with some common denominator when we are adding or subtracting in general fractions, and that also applies to rational expressions. So determining that common denominator often means we're going to need to manipulate each term's denominator without actually changing what the expression is equal to. So we will in essence be multiplying by 1, but that 1 will often be some number or expression divided by itself. So you see our example here, it could be like 3 over 3. That's equal to 1. X minus 1 over x minus 1 is also equal to 1. So we can multiply by expressions like that, where it's something divided by itself in order to manipulate our denominator. Once we do have common denominators, then we can actually add and subtract the numerators. And with our result, we can reduce when possible. So we're going to be building on what we talked about in the last section, 3.1. Okay, let's look at an example. So our first example, we've got 7x minus 4 over 4 minus 3x plus 2 over 3. So our first job is to come up with the common denominator. So we're looking at our current denominators of 4 and 3, obviously not common right now, and we want to come up with their lowest common multiple. Oftentimes that's going to be just the numbers multiplied together, the product of our denominators, but we'll look at examples where it's not literally just the product. In our case, we're going to be aiming for that product 12 to be our common denominator. So now we're going to multiply each of our two terms here. Again, I'm referring to this first piece, 7x minus 4 over 4, as one term, and then the 3x plus 2 over 3 as the other term. We're going to multiply each of them by quote-unquote 1 so that we get our common denominator. So I'm going to multiply my first term by 3 over 3. Remember, 3 over 3, that's equal to 1. So when we multiply by 7x minus 4 over 4, we can see our denominators are going to get to 12. So then, let's see, we will subtract the next term. And what do we need to multiply that next term by to get the denominator of 12? We need to multiply by 4 over 4. So we're multiplying by that 3x plus 2 divided by 3. Okay, so it is important to remember when we actually do this multiplication step that we treat the existing terms and these numerators as basically we need to use the distributive property. These are terms that are being multiplied by 4. So let's write this out. We're going to have 3 times 7x minus 4. We'll work on that distributive property in a second. Over 12. Notice all I did was multiply the numerators and multiply the denominators. And we're subtracting 4 times 3x plus 2. And our denominator is now 12. Okay, so now we've got to go ahead and distribute. So we'll distribute the 3 across the parentheses, and we'll distribute the negative 4. Notice this minus will come into play here. Okay, so let's look at what we get. 3 times 7x, it's going to get me to 21x. I'll stick with the white here, 21x. 3 times 4, or negative 4, gets me to negative 12. All right, negative 4 times 3x, negative 12x, and negative 4 times 8 gets me minus 8. And we still have that common denominator of 12. All right, now we just need to go ahead and combine the like terms. So I've got a couple terms that involve x and a couple terms that do not. So we want to combine those pairs. So overall, let's see, 21x minus 12x. That should get me to a 9x. And negative 12 minus 8, that overall gets me to minus 20 divided by 12. I still have that common denominator of 12. And this is where we want to look at, okay, we're pretty much done simplifying as far as combining like terms. Is there any way to simplify this fraction? So I'm looking at 9x, negative 20, 12. Do they have any common factors? They don't. So this is our final answer. This is our fully simplified answer. Okay. Let's look at a slightly more challenging example. Okay, so I've given myself a little bit more space to work here because I know we're going to need it. Alrighty, with this type of problem, notice our denominators. They are currently much more complicated than the last problem, and our first step is going to be factoring them. So we're overall aiming to find a common denominator, but in order to get a common denominator, it's going to be really helpful to have these denominators factored. So let's go ahead and do that step. So let's factor this first trinomial, x squared minus 2x minus 3. So I'm looking for those two numbers that multiply to negative 3, add up to negative 2, and that should be negative 3 and positive 1. That tells me my factors are x minus 3 times x plus 1. Okay, let's look at the next set of factors. 3x minus x squared, I should have said the next denominator, and we're going to factor this. And let's see, that factors as x times 3 minus x. I'm going to leave that as it is for now. And let's see, I'm just going to move this over a little. My last denominator, x squared plus x, that's going to factor as x times x plus 1. So I'm seeing that we have some similarities here, but there's something important I want to call out right now, which is that we have a set of factors that are almost identical. This x minus 3 and this 3 minus x. If possible, I'd like to rewrite one of these so that it matches the other. And I'm going to be able to do this by factoring out a negative 1. So I might just choose to work with my 3 minus x. What happens if I divide both of these numbers, 3 and negative x, by negative 1? So I'm factoring out a negative 1. That would make my 3 a negative 3. 3 divided by negative 1 is negative 3. That would make my negative x a positive x. So I would have negative 3 plus x. Well, what if I just rearrange their order? So I would have negative 1 times x minus 3. Notice now that actually matches. I've got an x minus 3 and an x minus 3 now. So rather than treating those as like separate factors, I can say, oh, actually, these are the same. So I might rewrite the factors for this middle denominator as negative x times x minus 3. Okay, now that we have everything factored, we want to determine the lowest common multiple. So that's what we're going to work on next, is determining what is my lowest common multiple of all these sets of factors. So essentially, we're going to be taking the unique factors from each of our denominators. So it looks like between all of these guys, I do have an x minus 3. So the lowest common multiple is going to include an x minus 3. It's going to include an x plus 1. Notice I've already got an x plus 1 over there. I can eliminate that x minus 3 there too. So my lowest common multiple will have an x plus 1. Now what else is here that I haven't already included in my lowest common multiple? I have a negative x and an x. So I'm going to say, well, x is part of my lowest common multiple, and so is negative 1. I don't need an x and a negative x. We can just have one x and a negative 1, because that's really what this term is, negative 1 and x. So that tells me my lowest common multiple can be written as perhaps negative x times x minus 3 times x plus 1. My lowest common multiple is also going to be my lowest common denominator. Let's see if I can spell common. Now denominator, that one's the harder one. Okay, lowest common denominator comes from our lowest common multiple. So this, therefore, is going to be the denominator we aim to have for each of our 3 terms up above. So you'll see the last sort of little step I have outlined here says now we need to multiply each of our terms from the original expression by the factors needed so that we get our denominator to be that lowest common multiple. So I'm going to go to the next page so we have a little bit more space to work here. Okay, so let's rewrite that lowest common multiple maybe up in the corner here, or lowest common denominator. So LCM or LCD. We said that was negative x times, let's see, x minus 3 times x plus 1. Okay, so let's see, our first term was x plus 17 over, and I'm going to write this denominator as we had factored it, x minus 3 times x plus 1. So comparing that denominator to my lowest common multiple, the only thing I'm missing is this negative x. So that's the only thing I need to multiply the denominator by in order to get it to be my lowest common denominator. So of course we're only still multiplying by 1, so we'll need to multiply by a negative x over a negative x. Okay, so we'll do that step next, but let's go ahead and look at what we need for our second term. So in this second term we had 3 over, and I'll again factor it as we had negative x times x minus 3. So what's missing in that denominator compared to our lowest common denominator? We're missing the x plus 1. So we'll multiply this term by x plus 1 over x plus 1. Okay, our last term, we're going to do the same thing. This time we had to start 1 over x times x plus 1. And what we're missing from here, compared to that lowest common denominator, is x minus 3. Almost just x minus 3. We're missing x minus 3, and we're missing a negative. So we'll multiply by negative x minus 3 over negative x minus 3. Barely have enough space to fit it in there. Okay, so let's actually do this multiplication step. I might write all of my numerators out in the same numerator over the same common denominator. What I mean by that is I'll have, for my next line, negative x times x plus 17 plus x plus 1. Notice the parentheses here are kind of important. I might put my 3 in front here though. 3 times x plus 1 minus, and let's see, I've got a negative minus a negative 1 times x minus 3. hopefully we're seeing right off the bat that this minus and negative is going to result in a plus sign. So we'll actually be saying plus 1 times x minus 3. Okay, so that's my very complicated numerator right now. Let's look at what our denominator is. Well, that denominator is my lowest common denominator that I had mentioned before. So negative x times x minus 3 times x plus 1. Okay, now our job is to combine, basically to simplify so it doesn't look this crazy. In general, I'm perfectly okay with the final answer being in factored form. Honestly, I prefer that if possible. It's not always possible, but that's kind of what I aim for. So I am not going to, at any point, multiply my factors of the denominator all together. I'm just going to leave them just like this. Okay, so what happens with my numerator when we do go ahead and distribute wherever we can? So we'll distribute, I guess, 1 across x minus 3. Not much going to happen there. But let's start at the beginning. Negative x times x plus 17. We get negative x squared minus 17x. Then we have plus 3x plus 3. And then we have plus x minus 3. Okay. And that's still over that same denominator. X minus 3, x plus 1. Okay. We've got a lot of terms that we can end up combining here. So I might just like circle some of them. I see we've got a negative 17x. I kind of want to use a different color there. Yes, okay. Negative 17x. We've got a 3x, and then we've got just a plain old 1x. We also have a 3 and a negative 3. Interesting. Looks like those are just going to cancel each other out. And then we just have a plain old x, negative x squared. So overall, we've got a negative x squared and a minus, let's see, what did I have here ultimately? Minus 13x, right? Yeah, because negative 17 plus 4x essentially. Okay. And our 3's, those just cancel out. All right, so we've got negative x times x minus 3 times x plus 1. All right, simplifying is our next step. I think I can factor that numerator. Let's factor that up here. Let's factor that as maybe negative x times x minus, or x plus 13. I like that a lot because look, our negative x in the denominator, that's going to get canceled out. Whenever we have specifically common factors, things that are being multiplied by everything in the numerator and being multiplied by everything in the denominator, they in effect cancel each other out. They ultimately just equal 1 over 1. So we can cross those negative x's out. So what we're left with ultimately is an x plus 13 over x minus 3 times x plus 1. Can't simplify that any further. There's no common factors to simplify or cross out. So this would be our final answer. Okay. Next up, I've got a few problems here that you could use to check your understanding. So I want to give you a moment to consider copying these down and solving these. Maybe pause the video because on the next slide I actually have the answers. So I'll wait, give you a chance perhaps to copy these down. And in about 5 seconds, I will go ahead and show the answer. So you probably want to pause. 5, 4, 3, 2, 1. And here are our answers. Okay, let your teacher know, of course, if you have any questions, but thank you for listening today and have a lovely day. Stay healthy, everyone.